When we last spoke, I talked about needing to implement a PID for my speed control. And so I've had a little bit of time to do that. It's had its, as usual, its ups and downs. I've had 2 or 3 attempts at it, but I was out. I've got a little bit of video to show, but was doing some testing in the yard. Started off with a KP value of 74 and a linear X of 0.3. And then I did another test at linear X 0.5 and 0.75 because there was a material difference between running with a KP at 74 for that low speed versus 0.75. Bottom line is I've got something working, but I don't think it would be very good for low speed. So I'm sort of thinking that I'm going to potentially need different PID settings based on the target speed. And I'm not talking about having 20 different options, but maybe 2 or 3. But I just need to do more field testing. And one of the challenges I have here is after it runs about 45 feet, I need to stop it because I'll run over the neighbor's yard. I need to remount my GPS antenna that broke off during some testing. I wanted to have 2 ODOM statements, one from the wheels and one from the GPS in case RTK drops. Jeff went through a process of debugging some code. I'm going to have to repeat that on my end and try to get that path planner working. So that's what my next few steps look like. I mean, it won't mean much to you, but my servo forward speeds change, and they generally change if the servo is set at 285 versus 300. So there's not a huge range in here to adjust. And one of the nuances of this is you've got to give it a higher value to get it to move, and then you've got to bring the value down in order to stabilize. But let's see what, where is that? Dun, dun, dun. Maybe, nope, not in there. Trying to get to, well, here's an easier way to do that. This is a screen capture video while I was testing, and I know I should be using ROS bags and replaying it and get Plot Juggler running again on this machine, but I haven't got all that done. So basically what you see here are 4 different windows. One that's just informational statements. These are this is where the ROS core was started. This is a ROS topic specifically on the speed of the right wheel. And this is a window where I was issuing ROS topic pub commands in order to give it particular linear X targets to meet. So that's what it looks like. And if I go to, I have to get back to my timing. Let's see, let's just do this. So 1539. What you'll see is this logic, that logic value is saying what part of the code is running, and you're going to see that change. And then you're going to see the servo value go up and the speed come up while the PID was, or the KP was, I'm standing at the tractor at the moment. adjusting this KP, getting it to move, and obviously there's a correlation between the P and the servo value. So if you watch at about 290, you'll see the speed pop up, maybe 291, maybe 293. Yeah, this has to get up to about 70, as I recall. Yeah, so there it goes. And again, it's supposed to be hitting 0.3, and it's vacillating up and coming back down. Now I'm not standing it, it's moving across the yard. That was my testing process. And I did that for, as I said, multiple tests. So progress, I'm in the yard testing. That's a good day, right? But I still need to home in on what are the right PID values now that I have that in the code. Speaking of code, and then I'll finish off. I ended up with, this is the main tractor control software that's out on GitHub. And at the moment I'm using this velocity control 2. And I think what helped me out significantly was going back to this where the KI value times out after a certain number of, I think it's basically set for 2 seconds. And that seems to help me. I did have another velocity control, which was very, I think they call it bit bang approach. Basically, it just looked up in a table what's the right value based on the target speed, and then adjusted the servo value up or down. If it's not at the target speed, that became completely unworkable and was just too slow to respond. And then the other PID was a more exotic, an actual class and a very traditional PID where you have a K, a P, and an I, and it's all working. And someday I might try to make that work, but at the moment I'm where I'm at with the one that I've got. So as I said, the next steps for me are get the antenna mounted so I can have an ODOM statement out there, work on getting a second ODOM from the wheels, and repeat the process that Jeff went through to get the path planner to work. And then test that, obviously.
On the wheel ODOM, are you doing any math to compare or to merge the two drive wheels, or do you have an encoder on each wheel?
I do have an encoder on each wheel. So each of them are capable of providing, meters traveled and speed and whatnot. Currently, I just haven't put that I haven't taken that data and created, I think what ROS calls it is a pose statement. Jeff is probably more familiar with all that than me, but I just need to take that data and turn it into a ROS position. But my encoder, just as a reminder where that's at, my encoder data at the moment, I've got a separate microcontroller monitoring the right speed and monitoring the left speed. Code is exactly the same except for one statement where it gets reversed because the way the gears are going, this is what it looks like. It's reading this thing called an AS5048B, which is their I2C version of this encoder. And this is the code that's currently working that publishes a left speed and meters traveled statement.
And he doesn't have to ensure his back wheels are going at the same speed, because since we're running Ackerman, he's got the engine and a differential, so it automatically knows how fast to make the wheels go depending what direction you're pointed. And you're thinking about the fact you have differential drive, you may have to control the speed of the two to get it to go straight. I think that was your question.
Well, no, it was more of not to control it, but to know how far the vehicle had traveled, so that if you are turning, the assumption would be one wheel would be turning more than the other.
That's true. And in fact, you take your two encoders and there's some standard odometry equations you run it through, and that retrieves your forward speed. It retrieves the angle, your current angle you're driving, and then from that it computes the new XY position where you are based on the last timestamp. So that just all that just falls out. And whether you have a differential drive or an Ackerman drive, you can use the same equations and it'll tell you how fast you're going and how far you've gone. So yeah, that all with an encoder on each wheel, that does work.
That's what I thought. I just wanted to. It sounded like he was only using one odometer, and that's why I was asking.
Yeah, I was just, I mean, I was echoing in ROS language, you call it echoing a topic. I was just echoing the right, just to, because I knew I was going straight. And yeah, I was just echoing that.
Okay.
So bottom line, a little bit of progress. Miles to go before I sleep. I think isn't that a poem or something?
It's something like that, yeah.
Yeah, that's by Albert Frost.
Oh, there you go.
Somebody Frost. I think his first name's Albert.
There's the English major. That's it for me.
Okay. Well, I will go ahead and go next then. Let me find where I'm wanting to be. Okay. So I got my mounted the battery holders and can put the batteries, although I had to move one of the battery holders because I didn't account for how big the battery was and it ended up touching the wheel. So I had to raise it by 1/8 of an inch. So now I've got 1/8 of an inch spacing between the battery and the wheel. But since this is going to be my indoor test, I don't exactly have to worry about it picking up snow. I then got the batteries wired into a bus, and the bus then to my set of 3 switches. I've got my master switch that disconnects all of the grounds, and then I've got a switch for the 2 batteries. One will be used for the 5-volt bus, and the other will be for I'm going to call it the motor bus. I have both of those switches feeding directly into a fuse block. And then from the fuse block, it goes, for the 5-volt side, it goes to my 5-volt regulator, which then comes back to the fuse block, and then to my 5-volt bus. And in the case of the motor, it goes directly from the fuse block to the bus. So that means I now have a 5-volt source on the robot and a motor power that I can easily connect up. Um, yeah, that's that. I then updated the distribution schematic so that the fuses match which fuses I'm using, and the I added labels on the wires so I know which ones go where. I was able to load the Ubiquity robots that you guys sent me the link to last week onto my Raspberry Pi. I've not tried starting up ROS on that, but that's it says it's there, so I'm gonna try and get that going. That's plans for next week. Didn't have any time to work on getting ROS on my laptop. So for this coming week, I'm gonna, now that I've got my new itsy bitsy, I'm gonna add the A to D resistor network for voltage measurement. Also test out the communications with the serial on the Raspberry Pi. Again, I plan on using 2 of the serials on the itsy bitsy. Serial 0 is kind of hardwired to go to the USB, so I'll be able to remote program and debug over that, and then I'll have serial 1 communicating to the Raspberry Pi. Once I've got that all worked out, I plan on moving it to from the solderless breadboard to a breadboard that I can then mount on iSnow 1, which is what I'm calling my testbed robot. The assumption being that iSnow 2 will be what will actually go out and remove snow. I need to get the VNC server working on the Raspberry Pi. I went out and got a monitor at Goodwill for $8, but I'd rather be able to work from my laptop to be able to program the Pi and so forth. Need to get ROS loaded on the laptop and then start playing with different aspects of ROS, which leads me to one of the questions is now that I've got ROS or will have ROS loaded, what should be some things I should be looking into to get a better understanding of how it works?
Start with the ROS tutorials. So you look on the install page, it says install all the stuff, and then it says then go on to the ROS tutorials, and they've got a whole bunch of things they run you through to play with to figure out, how to make this stuff go.
Okay. So something else I want to do.
One in particular that I would advocate would be something called Turtle Sim, and just getting it to run in simulator, and they'll show you how to use your keyboard to control the direction of that in simulator. And then for me, another interesting step to think about is plug a joystick into your computer where the simulator is running and control it via a joystick. I mean, and I'm happy to explain that in more detail, but those would be 2 things, in that learning journey that I would advocate.
Okay. I've accessed GitHub before, but I've never set up a project in GitHub, so I need to investigate how to do that. My testbed robot already has 4 bump sensors on it, so I want to look into maybe how to incorporate that into ROS. I'm sure there's other robots that have bump sensors, so I just need to go looking for that. Likewise, I've got 6 infrared range sensors already mounted, and it'd be nice to be able to incorporate those onto ROS and let it recognize and respond to those in case I want to do line following, for example, or whatever I want to do. And then how to segregate ROS functions between what I want it to do on the laptop versus controlling the robot on the Pi. So those are kind of some of the longer range investigations I want to understand. Any questions?
And those range sensors, I've never used them. Do they work in the day or outside? Do you have any real world views on whether those things work outside?
I do not. This particular robot's never been outside. But I believe they are modulated in such a way that they can handle outdoor light.
Also, that setting up a GitHub is easy after you've done it once or twice. I wrote my instructions down somewhere. I'll dig those up and send them to you.
That would be appreciated. Jeff, do you use GitHub for your
I don't usually. I don't do any software control. And if you want, you can set up Git on your computer and not go out to GitHub out on the internet if you just want to keep track of your own stuff. But if you want to point people and say, here's what I'm doing, then it's probably easiest to just do a GitHub. You just put all your code up there, and then every time you make changes, just update it there. So and one of these days I'm going to turn my computer on and it's going to say, nope, not going to fire up, and I'm going to be screwed. I'm going to lose everything. So that's another reason that it backs everything up for you too if you put it out on GitHub.
Okay.
Yeah, I'll second the backup feature of putting it out on GitHub. That definitely has saved my bacon a little bit.
Because that can also do version control, I understand.
It does, but I'm just I'm a single guy just controlling it myself. It's more so I can share it with you guys and it's in a public place. And the backup. Those are the two reasons why I put mine out there.
It does do version control if you know what you're doing. You just have to go through and figure it out to do that. So if you're going along and it doesn't work at all anymore, you can click on it, you can back up to your previous version, and you can go ahead and run that if that was running. So that you can do all that stuff.
Okay. Well, that's one of the aspects that I do want to do, because I've been doing it by actually changing the file name after I get a successful run of one functionality. Then I'll rename it to a new version number. But I also, in the code, keep track of what version number I'm doing what on, so I can kind of go back and understand what I did when.
Well, actually, on GitHub, when you make a change and you say, okay, this is working, you go to check it in, it says what comment do you want to put on this, so you can see I just added the new battery sensing, and then check it in, and then later you come back and look at the history and say, oh, here's where I added the battery sensing, it was on this particular version. So that it's real handy stuff if you're willing to figure it out and use it on a regular basis, so you don't forget how it works.
And I think VS has a add-on, so you can just link in directly to that and keep that in sync pretty easily. But I've not used it yet, so. That was all I had.
I'll point out, yeah, GitHub is definitely to your advantage if you want to figure it out and use it. So that's a good thing.
Yeah, the VS thing is, crazy simple to use. I was just trying to get it started here to show you. I mean, once you have it set up and connected, if you change any of your code, you're gonna, it's taking a little bit of time here to get going, but as Jeff said, it's a 3-step process. You change your code. There's a little button that's going to come up here about what's the verb? Anyway, you're gonna, why is this taking the platform IO is thinking? But you click here to, I'm going to say post the change. You put a comment here to commit the change, and then you get a sync button that says, I want to sync it with the, think about it as the the cloud version, which is, stored in GitHub.
Got it.
The other thing you got to work out is they also have branches. So I just have one. I have the master branch, but you could have a development branch, or if you're going to do something with, as Jeff was talking about, sensors and whatnot, you could have multiple branches. That's a level of complexity that I never bothered to try to figure out. But you can do that.
Okay.
Using VS Code, if you're using VS Code, it is a nice, so if I just put a space there, why am I not getting the, I'm not sure why I'm not getting it right now, but it's a click.
Did you save it after putting the space in?
There you go. Jeff knows how to do all this stuff. Stage, that's the verb I was looking for. You stage it. You put a comment there, you commit it, and then you sync it. And there'll be a new version now in the repository once it's all been set up.
Okay. Cool.
And if you know what you're doing, or you're willing to spend the time, you can go out to GitHub now and say, pull up that file. And then there's a button you can click on and say, show me the history. And it'll tell you every time you changed it and committed it, it'll show you all the different versions that just happened. I go poking it. I can never find out where to do that. So, but anyway, it is real handy if you're willing to figure it out. And another thing is, if you have multiple people working on the same project, then it gets messy because you have to merge stuff together from different people. But if you're the only one working on it, you're the only one putting stuff in, you don't have to carry. You just make a change and say update it, and you're all set. If you've got a project where 10 different people are working on it and you got thousands of files, then you always have the problem that you go to say put the changes in and say, oh, that conflicts with what somebody else did. So you have to go through a merge process and make the stuff work. But just using it yourself, it doesn't work out too bad.
And so here you can see this folder changed 1 minute ago. The comment, the whatever I typed in that commit field shows up there.
Click on that test that you were just hovering over.
The word test?
Yeah. Because depending where you click, if you click on test, that'll give you some kind of history, I think. So that shows you what the actual changes was he just made.
Okay.
And if since that was showing, I think, an entire directory, this would have all the changes in that directory will show up that was made for this time. And then what he was doing just now, he was, if you back up one line and click on the source file itself. So if you now somewhere here, you can click to find the changes. Yeah, see what that does.
And so this is adding the space, and this was something, you know,
So click on that. What's it do? Okay, so it shows you the same thing. So this lets you do it per file, and the one up above says anything you changed in that directory and then committed, it'll show you all the things you changed.
Gotcha.
And if you go back through the history, then like he was saying, well, down here, you know, just grab a random one there. You can click on it and it'll say, this is that big long number there, that the letters and numbers is the name of that version. So theoretically, you can go to your computer and you've got a Git directory. You can say, it's I can't think of the thing called, but you can just type in something that says, give me this version, and put that in, and it actually puts everything on your computer, sets it back to whatever it was at that point, and you can go and work on it or play with it or just view it. And then when you're done, you can just, you know, set it back to I usually call it the head, which is the last thing where it's at. So it's
Okay.
really powerful if you can figure it out.
Yes.
but for me, I use it to back it up, and so I can say this is where my code is, and it's in a publicly available space. But yeah, have at the version control stuff.
Okay.
One of the reasons I don't use it is because as soon as you put something out there, it says all of things. Oh, if you want to join in and help out on this project, here's the links to do it. And then all of a sudden you start getting people saying, well, here's an issue with your code, and here's I copied your entire repository. I made changes, so I'm going to issue a pull request. So I want you to go out and take my changes and merge them into your code. And I get to the point where I don't want to deal with other people playing with my code. So that's another reason why I don't do that. Other than you can set it to private, and then nobody else can get in it, period. Or I think there's other ways you can set it so other people can't do stuff to it. But that's just something that annoys me. That the original ROS agriculture stuff, I checked in the driver for the uBlock stuff. I had copied somebody else's stuff, made a couple changes, and put it out there. And then it turns out people were issuing what did I call that? They're submitting issues, and it wasn't sending anything to me to tell me they were doing that. So I had a bunch of people saying, well, this doesn't work, or how do I do this, or you should do it this way. And I didn't even know that was out there. So one day Matt sent me a message saying, oh, by the way, somebody should look into that. And I thought, oh, great. So that's, I could put a note on that says I don't care, and just ignored everybody. So once you expose it to the world, somebody's going to want to come in and start playing with your code and telling you how to fix your stuff, which could be good, but then again, you don't know if they know what they're talking about or not. So it's just one of those things. So something you'll learn as you go along.
Gotcha. Or I could just probably expose it just to you two, and
I don't know if you can do it like that. You might be able to do that. I don't know. Again, I just haven't looked into it, so I don't know what you can do. I know you can set it to completely private, so you're the only one that can look at it, but then I don't know how. I suppose you can set up groups, and you can do all kinds of funny things. So yes, that might be possible.
Google will be my friend.
Oh, definitely. You're going to get real cozy with searching for stuff, because that's just where you're at in the evolution right now. And so we'll see how it works out.
So it's up to you now.
Okay, so last week I was saying I was trying to decide whether to use a blue pill board under Arduino, I think is what I was saying. In fact, I was holding up various boards. I've got I got my blue pill board, And then I got the 407 board that like Juan found this. And it's just basically the chip on the board. So you give like 100 IO pins or something. And then I said, this is what I'm currently using on my Sammy 2 robot. It's just an eval board from ST Micro, and it's got this is the debugger section, and this is the actual processor that brings all the pins out. So this debugger section here is the equivalent of one of you can get that externally. You can buy these on Amazon, and it just plugs into USB, and it basically does the same stuff that whole end of the board is doing. And you just plug it into a board like that to do your debugging. So if you need to do debugging, you can hook that up. And if you don't need to do debugging, you just unplug that and not worry about it. So I was trying to get the Blue Pill to work with Arduino. And one of the things I thought it needs to do is, I said my color's all screwed up again, so just ignore that. So one of the first things to make it work like an Arduino, I wanted to get a bootloader. So I can just plug the board into a USB cable. And just like on Arduino, you say upload code and it just automatically loads it on the board and takes care of itself. So I started off on the Blue Pill, and I started digging, and it turns out there's two main what they call Arduino cores. A core is all the files you need to make a particular kind of processor run. And it turns out that there's for the Blue Pill board, these are all boards based on ST microprocessors. So you can get what they call the official ST I think they call it STM32 Arduino core. So you can get the official one from ST Micro, and then you've got the other one that somebody else has developed, and it's all based off stuff. I think Roger Clark originally created this, and it works differently than the ST Micro stuff. And then there's other people that have derivatives of the Roger Clark stuff. Well, it turns out one of the things I wanted to do, I wanted to get the quadrature encoders to work. So I found a repository. A guy from Homebrew Robotics said, here, I was playing with the Blue Pill board. So here's the quadrature encoders for a Blue Pill. And he put the code out there. And when I first started it, I tried to run it, and it wouldn't compile, and it gave me all kinds of strange errors about libraries and type mismatch type things. And out of desperation, I loaded the stuff on my Linux machine and loaded the ST Micro core, and bam, it popped up and says, oh, compiled just fine. So I thought, oh, okay, I'm all set there. So it turns out there's a difference between those two. The ST Micro is built on HAL libraries, which is something in the ST Micro world. They have various libraries. When you go to compile your code, you got the HAL, and then there's something in it called LL, which I think is low level layer or something. And then there's a previous one to all that called CMSIS. That's more just, definitions of go to this register, put in this value, and make it work that way. And the two may or may not be compatible. I'm not really sure about that. So if I pull up the big ST Micro IDE and run that, again, I have these same options. I can run it one way or the other to make all that stuff work. And back when I did this board, I pulled that up, and I think I'm using HAL libraries to make that work. And I had all that working, and I was happy with it. So now I'm trying to get that to run on the Arduino stuff. So when I tried to get the bootloader to run on the Blue Pill board, I went to something that Roger Clark had written. It's a bootloader you put on the board, and it's supposed to create a DFU programming interface, and it's supposed to work transparently with the Arduino core that he wrote. And then I think that stuff's been pushed into the quote official ST Micro one. And I played with that thing for a couple of days. I just could not get that bootloader to work. It loads onto the board. I can see it's doing something, but it would never, when you go to Arduino and say upload, it sends some secret codes out to the board, and you can see the board switches because the LED starts flashing on it, but the USB interface never switches from normal serial mode into this DFU mode. And I can't, no matter what I do, I can't make it do that. But you can move a jumper on the board. Yes.
At least on the Itsy Bitsy, if you hit the reset twice quickly, it puts it into the bootloader mode.
Well, this one's got an extra jumper on the board. If you move that and hit reset, it comes up when he calls perpetual DFU mode. So yeah, you can put it in the mode where it will do that. But then Arduino says, oh, I can't find your serial interface. So it will not try to proceed because you've got it in this forced mode that you used. And I thought, well, what if I just try to use it directly? So I say, put it in that mode. And there's something called DFU utility. And there you can say upload this binary file, and it's supposed to just push it out there. So if the thing's in perpetual DFU mode, you say run this utility, and you should be able to program the thing that way. Well, I couldn't get that to work. And then I also thought, well, once the Arduino comes out and says, here's the magic code, switch into DFU, and the board seems to switch and the LED's flashing some way. So in that mode, I said, okay, don't go through Arduino, fire up the DFU utility, and that one says can't find a DFU interface. So whatever Arduino did to it, it's still not trying to do the DFU. So anyway, I just kept going around and around on the stuff, and I've never got that bootloader to upload anything to the board. So I decided that I was tired of playing around with that and wasting time. So I found another one called an HID bootloader, and you load that onto the board, and then it again, there's this stuff hidden in the background on Arduino that knows how to talk to it. And I think when you say upload, I think it sends out a secret code to the board. It automatically switches into HID mode, pushes the code out, and when it's done, it resets. And in general, that seems to be working. I did notice that after you do that, you may have to unplug the USB cable and plug it back in because there's something's not completely switching right, but it seems to work. You don't have to move any jumpers on the board. You don't have to do if the board is running and talking to you over the serial port, then you can go ahead and upload it with Arduino. So that does appear to be working. But if you go in and say load anything with the with this module, that overwrites your bootloader, and then you're screwed. So then you have to go back and you have to reload the bootloader again, which is it's a fairly easy process once you figure out how to do that. I just got 2 command lines I execute, and it says, okay, you got a bootloader again. So anyway, that might be usable. You know, once you get that loaded on there, you might be able to unplug the debug module and just have it run off USB, and everybody should be happy. The only problem is if you do something, if you forget to turn on the serial mode in your sketch when you upload it, then it's not going to work, and you're going to have to go back. Because once you overwrite, they've got some other secret codes that gets downloaded with it onto your board. So your sketch is sitting there, it's secretly watching in the background for these keywords to come by. And when it sees that, it switches to the bootloader. And if you forget to enable that, or you overwrite that sketch with something that doesn't have that in, then again, you got to go back and reload the bootloader to get around all that stuff. But I think, you know, once you get in the habit of doing it right, it probably should just work. And so far, I don't think I haven't destroyed the bootloader other than when I plug the module in right over the top of it. So I was trying to get, I said I was trying to get the encoder stuff to work. And it turns out if I take the code from the Homebrew Robotics one and load it in under a Roger Clark flavor of Arduino core, that will compile. And I think I did get that to run, so I could, you know, turn my encoders and watch it come up on the screen and say the values are changing. And then I moved over to the ST Micro official core, and now that stuff won't compile. And I did a bunch of digging. It says, oh, you can use HAL libraries, which is back to the ST Micro stuff. And it turns out the main thing is, you know, ST Micro just has just mountains and piles of software to make all this stuff work. So they're trying to wedge it all into this Arduino thing, so you can write it from the Arduino section. And it's not documented well enough that you know what you should be doing or how you get around things. So I did a lot of digging through their forum, because they got a forum that's the basic STM32Duino forum, and that covers both of the types of Arduino cores that you can load onto the thing. And going through there, I found a page that said, oh, here, this code worked for me. He was actually talking about how you use alternate functions to move the pins. On the ARM processor, you can remap the pins. So if you want to put an encoder here, but there's a UART you want to use, you can issue a command and say, well, move those pins somewhere else, and, you know, make it work. But his whole point was he's trying to show how to write a function to do that, but also that he had this stuff to make the encoders work. So I was able to take that code and load it onto my official STM core and get it to compile. And with a little playing around, I could actually fire that up and turn the encoder and get it to show up on the screen. So I thought, I'm all set now. But somewhere in the process, I couldn't get that to work. And last, I think it was Saturday, I was frustrated and I thought, well, let me look into the Black Pill, which is the newer board. So here's the two boards. So the top one is the Blue Pill board, which has an F103, and the bottom one is a Black Pill board that has an F401. So the new one has four times the code space. It's got 256K of flash, and it's got 64K of RAM, which is 3 times what the Blue Pill has. And it's also, being an F4 processor, or Cortex M4 processor, it's got a built-in bootloader for DFU. So if you want, it's got this crappy little dip switch on here. And it's here, let me do this. Speaker view. So it's got this crappy little dip switch on here. It's a 3-position dip switch, just little microscopic switches on it. Right now it's covered up with tape. You have to take the tape off. So what you have to do, you have to move one of the switches to a different position and press the reset button. And then the board comes up in this DFU mode. So as long as you have something that talks to DFU, then you can go ahead and program that. So from Arduino, what they expect you to do is you have to flip that switch, you have to hit the reset button, and then go on the tools menu. It says you can select, it's like STM IDE, no, it's STM programmer, and pick DFU mode. And when you do that, then it's smart enough to talk. It sees that interface, and it'll talk to it, and it'll work. But the disadvantage is you have to flip that switch. If you're doing development a lot, you just turn the switch on and leave it. So you just, when you reset or unplug and plug it back in, it's already in the programming mode. So you upload your code and see if it's working. And if it's not, you can just unplug the USB, plug it back in. It's back in DFU mode, so you can upload again. So you don't have to keep flipping the switch. Whether when you say, okay, now I got what I want, and you turn that switch off, you come back the next day and say, it'll come up and run like it's supposed to, but you say, I want to make changes. Well, now you have to flip the switch again and go through that whole process. Whereas on the Blue Pill, the way they've got that one set up, it's got jumpers on here. You can set it to, I think, the serial loader. If you move that jumper and hit the reset button, it goes into a serial loader. So there's a couple pins out here. You can hook up like an FDDI adapter to it and load it through serial. And once you get the bootloader, HID bootloader put on, you don't have to do any of that extra stuff anymore. You just simply, the thing's running, you go to Arduino and say upload, and it does. And supposedly we'll go back to running, but you may have to unplug the cable and plug it back in to get the interface to come back up right or something. So in general, you can make that work on the Blue Pill. So I was at the point where I ordered this new board, and I thought, okay, I'll just take, it looked like I could use the same code on the Blue Pill as opposed to the Black Pill. So I started up a new project, copied the code over, and said go. And to start with, I had various weird errors I had to track down. And I got to the point where it said it compiles fine. It said it downloaded fine. And when I run it, it would just come up and say, it's putting out the number for the encoder. It just always put out 0. No matter what I did, I couldn't get that to change. And I kept looking at it and thinking, well, I digging through more forum posts. And they say, well, try enabling this clock, try doing this, try doing that. And nothing I did would work. And I kept thinking, it looks like it's something to do with the clocks on the board. Either the clock for the timer is not enabled, or the clock's rate is the clock speed is out of range for it to be happy, or it's remapping. You say, turn on this timer, it's supposed to go out to these 2 pins. Maybe they had that definition wrong, so it's using the wrong pins. So I've played around this for several days. One day I went to bed at 6:30 a.m. because I was playing with it. And so just yesterday I decided, let me go in and, so I had one more intermediate step. So I loaded up the big ST Micro IDE on my laptop. So I went in with the full development system from ST Micro that has nothing to do with Arduino, and I created my F103 project. And I need some way to get to see what's going on. So I had the option of either hook up an FTDI adapter to a serial port on the board, or I had to figure out how to initialize the USB port to talk to me. So after about half a day of digging, I found some instructions on YouTube on how to set up the USB. So I enabled the USB port, and basically once you get it enabled, they just have a thing it's called like HAL USB full speed transmit. So you just call that, and whatever's in the buffer just ships it out like a regular serial port. So I got that, screwed around, got that to work. So then I had on my ST, the big ST micro IDE, I had the USB port enabled, and I could start it up, and it would print out the messages. I think to start with, I was getting all zeros again, and after doing some playing around, I got to the point where that would actually put out, I could turn the encoder and see the values on the screen. So I had that working, and I could look at everything all the way through. And I created a new project for the F401 and copied the code over and ran that. And no matter what I did, I'd get zeros. It would not see the encoder. So I was thinking, well, just out of desperation, I decided what I would do is I'd play with the clock stuff. So I went in, and finally I started modifying the clocks, and I got a picture here. Let's see, how do I do that? I guess say share screen. I want screen 2. Okay, assuming you can see that, that's the clock structure on an ARM processor. So it's quite an elaborate thing. And on the left here, you right now it's not set up for the external crystals, but on the board, on my board, I've got a 32 kHz crystal for the real-time clock, and I've got a 25 megahertz crystal for the main clock. The Blue Pill has an 8 megahertz board, or 8 megahertz crystal. So you have to put the correct crystal frequency here. You have to click on this to enable the fact you want to use the external crystal. And then over here, you have to pick, so you take the 25 megahertz divided by some value, multiplied by some big number, and then you divide it by 2 to feed all this stuff, or divided by 4 to get because you have to, this clock rate says 48 megahertz. That has to be 48 megahertz or your USB will not run. So on mine, this is just a random thing I found on the internet. So it's not what I have, but mine says take the 25 divided by 25. So I've got 1 megahertz going into here, and you multiply it like by 192 and divide it by 2 or by 4, whatever it came out. And that gives me my 48 megahertz here. And then it goes through here. You have to select to say, get the path for the clock coming through into here. And then this tells you what is actually coming out of what this block is generating. It tells you here what it's running at. And I put in numbers. So this said 48 megahertz. And then there's a bunch of other stuff you can do here to change what happens out here. So basically, when I was all done on my F103 board, all the big numbers said 48 megahertz, and all the small numbers said 24 megahertz, which this APB1 timer clocks on mine is set to 24 megahertz on the F103 board. And that once I had either 48 or 24 megahertz coming out of here, and the 48 megahertz for my USB, it turns out the F103 board would work, and I could just load it up, and that was all working. So I went to the F401, and it just would not work no matter what I did. So out of desperation, I went back to my clocks here, and I had this set to something like 72 megahertz or whatever it was. So I went back and tried to get the same thing where I've got the crystal coming in, and this says 48 megahertz at this point. And then out here, all the big ones said 48 megahertz. And this one might have said 24. Some of these, they say they're dividing by a number, and I don't know how, because they don't let you change it. If it's got the little pull down arrow, I can change that to something else and make it do something fun. But so anyway, by the time it's done, all these clocks here matched what my F103 said. And I went back and compiled it, and then all of a sudden it started working. I added 2 more instructions in there that I'd copied out of somewhere else. So I'm not sure exactly what fixed that. I'm still thinking it's something was wrong with my clock setup. And on the way the board is set up, I have no idea what the clocks are set at, because it's buried under, mountains of code. And they've got like 500 variations of processors that it supports. So you have to figure out, which version of the processor do you have? You got to look at that code. And theoretically, if I spend enough time digging through, I can find where they're initializing the clocks and find out how to you know, fine. I can look at all these numbers. So it'll say it's using the 25 megahertz crystal. It's using the external one. It says this mux will be set to this position. This is dividing by 25. This is multiplying by something, divided by something. And I can look at all these numbers all the way through, and I can you know, figure out what they should be. And but there's no way, you know, just firing up the board. I don't know what the clocks are set at right now. So I was thinking I might be able to cut the clock configuration stuff out of the big ST micro IDE and dump it into a function called Black Pill fixed clock. And then when I start up in my setup stuff, just say, call the fixed clock function. And then I can set it to whatever I want. So it'll bypass all the stuff they're doing. And I don't know how it's going to affect, you know, other stuff on the board if I start changing the clock speeds, but that'll be a quick test to see if that does indeed fix the problem. So I'm up to the point now where also on the Black Pill board, this fact here is my, well, here's my, this is the way I run my Blue Pill, where it's got, so the Blue Pill board, I just have the board. I've got the, I leave this debug module plugged in and just got the USB cable. And if I have the HID bootloader loaded, I could just load everything through the USB cable, but I just find it easier to just load everything through the debugger module while I'm doing development. So theoretically, once I get everything figured out, again, I can make sure the bootloader is loaded on the board, then unplug this debug module and just plug in the USB and make it work that way. And why did I hold this up? I was going to say blah, blah, blah. I forgot. Oh, maybe the fact that, you know, that's the way I can program it one of two ways on this particular board. And without having to move jumpers or anything, I can make that work. And then the Black Pill board is set up, basically it's set up the same way, where it's got the board and it's got the debug module. And right now I've got this encoder plugged into it. It's actually a motor with an encoder on the back, but that gives me a convenient encoder. So that's just plugged into the wires on that. And to load it, I can either, again, move that switch around and then press the reset and then tell Arduino to upload, and it'll do the DFU upload. Or if I've got this module plugged in, I just program it through that and make everybody happy. So basically, the Black Pill, which has the Cortex M4 processor, that's got the built-in bootloader for the DFU mode, and it's got the built-in bootloader for serial mode. So you can use either of those. And then back on the Blue Pill, it's got the jumper on there. If you move the jumper, it's got actual jumper pins. You have to move it and then hit the reset, and that puts it into serial bootload mode. So again, you got a couple pins out here, hook it up to an FTDI adapter. You can program it over serial, or once I load in the bootloader, that I can, you know, I can just, without doing anything to it, I can just load code from Arduino into it with that. So either way you go, I think it's the point where I've got the bootloaders figured out to where you can probably make it work. It's still on the Black Pill, where it's got those stupid little tiny switches, and you have to move the switches to get the bootloader started. So I'm thinking if I just solder a wire and run it out to a push button somewhere, I can just push that, and I could bring the reset and a push button out, and, you know, just for convenient on a breadboard, I could do that without having to move the jumper wires around. Now, on the other hand, if you're going to put it inside of a box, you can put your push buttons or switches on the outside of the box. So if it craps out on you, you could walk up and, you know, just externally do the combination of buttons, and that'll put it in a bootload mode for you. So, but it looks like, you know, I can reliably download either board now. And it looks like as of last night, I'm able to run the encoder on either board. And the fact that the encoder is a problem is because that's not a supported Arduino function. You know, Arduino's got, you know, it's got like servo, and it's got the set pins, and it's got the, you know, whatever the standard Arduino stuff is, they've got that stuff basically implemented on these boards. So if you're not trying to do anything special like I'm trying to do, it would probably work. Although none of the stuff seems to be documented as well as the official Arduino reference, or like say the Teensy, they've got the reference. All the Teensy stuff works. That's beautifully documented. Their stuff seems to work, and they seem to support a lot of extra stuff. So that's kind of where I'm at right in the moment. Today I need to go back in and see Was it actually the clock speed that fixed the problem, or I'd add a couple more instructions that I'd copied from some other random location on the internet. And so I've got them both running now, and I can go back through and start saying, you know, trim out those extra functions, see which one actually made the difference. And if neither one, if it turns out that it could be that the clocks really are the problem, so I just need to figure out, you know, determine, is it the clocks, and if it is, then figure out how to fix those. So I guess that's where I'm at the moment. Oh, the other thing I was thinking about was, you know, then how do you develop? Well, one thing you can do is get a piece of you'll get a standard plug-in proto board and just stick the board down, and then these are like the header pins with the extra long pins on, so you can actually plug that into the proto board. They have pins sticking up where you can just put the little jumper wires onto that. And in fact, the ones over here is 2 rows of those, so I got power and ground. I can get to those for, you know, extra, like the encoders, I have to hook those up. So the thing is, you can put these in and then just run wires from here over to the board wherever you want to plug them in. So that'd be one way to develop that. Another way would be to actually get a perf board and solder some socket strips down, and then plug the board into that, and then solder down your header pins for everything you want to plug in. And then you just hardwire everything, flip the board over, and on the back of the board, put all your wires to hardwire everything. And I guess one other option I came up with was, say you're going to do this, plug it into a plug-in proto board, and then have another, so you just grab a random board like this and solder header pins on here to use for connectors, and then just solder like stiff wire from all those. So you take those and just plug those into wherever you need on your board. So that'd be another way to do that. So I'm just trying to figure out, you know, what's a quick way that's going to be flexible enough that I don't waste a lot of time on it. But if I come to the conclusion that one of these boards will work, then I can proceed on from there. Well, the other thing I was talking about, the new Black Pill board has 4 times the code space. Well, it looks like anything you compile for the Blue Pill takes around 24K of memory. You know, even just doing a blink sketch takes 24K of memory. And a lot of that, I think, is to get the serial, or to get the USB drivers to work. It compiles code for that, and you know, it's got all kinds of stuff going on in the background on these Arduino boards. So maybe that's just the base level. It's going to take 24K no matter what. And then I was going to look at after I got the encoder working, see how much bigger that made it. And it may not make it all that much bigger when I add stuff. But on the Blue Pill, since I have to run a bootloader, that takes away from your total space. So I start off with 64K of flash, and the original bootloader was taking 8K of flash, but I could never make that work. When I moved to the HID bootloader, it only takes 2K. So now it means I've left with 62K of space, and when just loading the Blink program takes 24K. So, you know, I've got like an extra, what, 20 to 30K there to expand into the thing. So I don't know if I'd run it out of space or not. And then the Black Pill simply, you know, blatantly has 4 times the code space. So that wouldn't be an issue there. The other thing about the Black Pill be the Cortex M4, it's got hardware floating point, if that's of value to anybody. So on the Blue Pill, which happens to be a Cortex M3, which is the F103 processor, and see, it gets real complicated with all these different combinations and stuff. But on that one, that does not have hardware floating point, so they just do emulated floating point on that, which means it's slower and probably takes more code space to put in the floating point emulation. So there's, you know, just lots of little details like that to figure out, you know, what's going to work and how much screwing around is going to be to make this stuff work. So I could go with the Blue Pill. So I think when I bought the Blue Pill, I got like 3 boards for like $11 or something. So that's what, $3 to maybe $3.50 a piece. And when I bought the Black Pills, I happened to find a deal that was 3 boards for like 15 something. So I think I decided those came out to $5.30 a piece. So it's not much more money for the Black Pill board, but that's got that funny bootload stuff. So it's just trade-offs. You just have to decide what you want to use and where to go from there, I guess. And I was trying to think, is there any other funny things I need to do here? It's going to take me weeks to figure out. Well, they do have you know, and since Arduino has standard functions like say the servo function, well, what I can do is I can load the servo function on here and see what that gives me for, as Al was pointing out, resolution and speeds and all this kind of stuff, and see if that's adequate. And if not, I see they have something called the hardware PWM timer library that I can load onto this thing, and then theoretically, you know, I've got 16-bit resolution at up to like 70 megahertz or whatever on the PWM if I really want to go that way. So it's just gonna be a matter of taking each function and figuring out, you know, is it supported directly, and if not, then can I find somebody else's libraries, or do I have to do it from scratch? Now, another thing that comes up, trying to use another thing I have to think about trying to switch over to Arduino, there's a lot of stuff going on in the background and you don't really know what's happening. And also when they initialize the thing, they're probably going to grab some of the internal peripherals and use for themselves. You know, bare minimum, they're probably gonna have at least one timer that they initialize. That's gonna be your time base. So, you know, when you do a millisecond timer or whatever, it's probably running off that. And so far I haven't found any list that says, do not use these timers, because we already used them. And I can't even think what else internally might be, maybe is being used. So I did on that one, I just said it's got the hardware PWM timer library. That one right in there says, here, you can use these timers with this. It says, do not use these. It says, do not use 2 or 3. And it turns out 2 and 3 are two of them I could use for quadrature decode. So that's an issue. But I can't find anything on the big package saying, you know, just in general, do not use these peripherals because we already use them. And I think if you go to the Arduino website, they're going to come right out and say that somewhere. And it just doesn't occur to these people. That's one of the important things for people to know. So it's going to be a lot of it. You have to try it, and if something crashes, you have to pick a different peripheral or whatever, I guess is the answer to that. So at this point, you know, I can get the boards to load. I can get a bootloader to work on either one. One is probably easier than the other. I've got the quadrature encoder stuff working. I have to prove it works on both channels because I got two motors, and then I have to talk to that Citron driver board. So I just simply need 2 pins. I need a direction and a PWM for that. I've got the RC servo on the front, so I just need 1 pin for that. And I think I was going to read some analog stuff, so I have to just verify their analog reads work the way I think they do. Because for instance, I want to stick a pot on my board, so as I turn the pot, it'll turn the RC steering in the front. So I can, as I'm doing that, I can print out the numbers saying, here's the number I'm sending to the servo to know what the positions are. So that way I can just run it, say turn the pot and turn it this way all the way to one side, whether it's left or right. And then when I get that, then look at the numbers I'm printing out and say, okay, that's the value for that. Then turn it the other direction all the way and write that number down. Then go back to the center and write that number down. And Al has gone through this many times telling you how to do that. It's just that I'll have the option of, you know, just load on the program that says read the pot and turn the servo and print out the numbers while it's doing that. So it's that's something else I want to do is, you know, verify I can do that. And then so if I decide that the USB is going to work for pushing the data back and forth, then I can try to get, you know, some kind of communication between my little board and a ROS computer. So I did find the example that says, here's how you run ROS Serial on an Arduino. And that does appear to run on my Blue Pill board. I haven't tried it on the new Black Pill one yet, but you know, that might be, so I have to incorporate that in there too. So that's kind of my plans at the moment. Just, you know, verify, do I need to change the clocks on this one board? And then try to get, say, if I'm going to use ROS Serial loaded on both of them and verify that's going to work. And just simply go from there. You know, back like we were talking about the encoders, if I can read the 2 encoders, then I'll drop in the, you know, six to 8 lines of code to
Thanks, Al.
get the odometry to work.
Do you have, or what are the thoughts on putting micro switches on the on your turning arms, so you know when you've reached the ends, so you can
I thought about
have
that.
I guess an extra security that you're not going to break something with it.
Yeah, and I thought about that on my current robot, and I went to look at it, and I decided I don't have room to mount micro switches on the axle, and so I haven't done it there. And then the other thing is I bought these little Hall effect sensors that are just like, they look like a little 3-pin transistor, and you can either get it soldered to a board just so you have some convenient way to wire it up to it, or I can just solder wires onto the chip and put heat shrink on each one, and that you can just glue that on anywhere. And if I glue a magnet on the steering parts, I might be able to get that to work as a like an end limit sense. So then when I sat there looking, I realized on my new one, I kept thinking, I don't have room. I got all this linkage and all this crap back behind the axle. I thought, well, I could just mount it to the front of the axle. So as the thing comes around, I got, there's nothing in the front. And then when my block that my axle is bolted on, as it comes around, I can just put a switch on the front there. So I need to get some kind of adjustment. So I decided this is where I want it to be, and then have it so it activates the switch, whatever that position is. So I could add that, but that's more playing around that I haven't got around to. And once you have that, you could even just have a function that says, run the thing all the way to the left, run it fairly slowly, run it all the way to the left until that switch comes on. And then you've got the number that you're using. So you record that number and then run it all the way to the right and hit that switch and then record that number and then go back to the center. And at that point, you can just say the center is basically, it would take halfway between those two.
Right.
Assume that until you go drive it around. And there's Owl has found out if you're driving forward and watch your value either off your odometry or your GPS, if it says you're turning the left or turning the right, then you just tweak that number so you could actually have a program that would calibrate that. And then so when the thing's going straight, you don't see any change in the heading. So that would be another way to do that. And the other thing I thought about, you were saying put switches on it. I was also thinking about trying to mount potentiometers on each front wheel. The steering joint on the front, the steering joint on the left, the steering joint on the right. I could put a pot on each one of those, and that would be another indication, because that'll give you that way you could record that and get the transfer function, because the Ackerman steering is not linear from the left to the right. And that way you could, if nothing else, you can just plot that out and use it for information later. But I was starting to think, well, again, trying to mount a pot onto those things is going to be more mechanical screwing around, and I'm not sure, I'm really looking to do that at the moment. So,
Okay.
So the original question, did I put switches on it? I haven't yet, and I've thought about it. And I'll use micro switches, which should be quite repeatable, or I could use the Hall effect sensors. The thing I was thinking about a Hall effect sensor, I don't know how repeatable there's going to be, because you got, say, just a magnet sticking up like this, and you got, so the sensor's coming over the top. I don't know at what point that's going to come on. So, maybe getting a nice little skinny rod, get a small magnet like this as it comes across the top, you might get a better indication of where it's actually turning on and off. And then I thought, well, if you have a magnet, you put like some kind of a steel tube around it, and that way the magnetic field will be this. The magnetic field is not going to go way out here; it's going to go like straight up down to this thing. So maybe that will make it more repeatable on the sensing too. So I've given all that a lot of thought, and just had the ambition to dig into it.
It was one of those lessons learned that we went through with the high school robotics team, where they had a drive screw for lifting something, but decided not to put the recommended kind of the okay, don't go beyond here point. And it ended up just there was so much power that it just literally destroyed the robot.
Yep.
And that was where they got some experience, because they didn't get what they wanted.
And the other point that I just made was, if you have switches on your steering, and you have switches like Al's got his transmission moving back and forth, once you get those on there, that tells you where the limit is, then you could just have, a little calibration routine, just say fire it up, and it runs it over to that one, and records it, runs it there and records it. And then also on my RC servo on the front, since the new one has a position output voltage, then I could run that to an A to D, and that, because you want to verify that, when we first started up, um, it, and not only a calibration, but every time you start it up, you could run through a sequence that says, verify that everything's working right. So you take your steering and slowly run it over to the left until your switch comes on, and then verify that, the position where it is what you recorded early, and take the output of the servo, the position, and verify that's in the correct spot, and then run it all the way to the right, and just verify that your steering is doing what it's supposed to before you turn it loose, before you crank up the power and just let it have at it. So that, a lot of things on your vehicle, you could do that. So when you first start up, you just say, I'm going to do this little song and dance and drive around and verify that all this stuff is doing what it's supposed to. And the other advantage of being able to read out the position of the servo, let's see, is that going to tell you that? Because if something slips or comes loose, you want to know that too, because as you say, if you don't, it might smash the entire thing and do a lot of damage. So, just while the thing's running, if you can compare stuff and verify that it's doing what you expect it to. But first of all, I just want to get it to move so that.
Yeah, I not discounting that. I just was asking.
Yep. And the way mine's set up right now, if I turn it too far, I don't know if it's going to break anything or not. My previous one could have broken something because it runs it up against a physical hard stop. Right now, I have no physical hard stops. I think it just simply, the linkage does something weird and it starts coming back. So you're moving to the right, is working. You go past the top dead center of that, you keep going now, it starts turning the steering back the other direction. So I don't think it's going to break anything, but it'll still be good to know that you're within the range and have someone to control that. Control it and or verify it.
One other way to potentially detect a fault situation might be to monitor the amps that the motor is drawing. I've thought about using that as a mechanism to see if I've got something out of line, but it's just, there's probably multiple ways to skin that cat.
And I was going back through ROS agriculture videos, and one of the videos started off, and Matt showed a picture of a lawn tractor sitting in the yard, and obviously one of the front wheels is cranked off to like 45 degrees, and the other one wasn't. And he said, "So how do you detect this?" And we were about to go into a big discussion about how you know that's a problem and what to do about it. And first of all, the question is, well, why did it happen? He says, well, I forgot to tighten the bolts, and he said he checked and he hadn't tightened up any of the bolts. But anyway, that happened. And as a human, you look at it and say, oh, well, the steering's screwed up, but the vehicle doesn't know that happened. So we were about to dig into that, at which point somebody interrupted and says, well, I've got this other problem. So we didn't go ahead and discuss that, but all these things about, having switches on it, having the fact that you can track, like I was saying, if you put a pot on both front steering joints, then you expect those to track in a certain way. And if they're not, you'll know that the linkage has fallen off or something is broken. So that's a whole discussion that, somebody should sit down someday. We could have a whole meeting discussing things like that. How do you know if it's doing what it's supposed to or not? And so he kept talking about the safety node, where he was going to have something that would go out and monitor lots of different things and say, are these within range or not? And if they're not, they would just tell the vehicle to come to a stop or shut it down or whatever. So yeah, it's all that stuff's all related.
Well, I kind of plan on doing that with the bump sensors, so that if one of those gets activated, it's immediately going to stop both of the motors.
Yeah. So I think that's all I had to say about about my boards I've been playing with. And the next step is decide, is it really the clocks that are wrong? And if it is, then figure out how to fix that.
On the Black Pill, once you get those dip switches set, do they stay set?
Well, if you want to download the new code every time you hit reset or plug it in, you leave it set. But what you have to do is if you're just running normally, so all the dip switches are off, you're running normally, you want to put new code in, you have to turn the dip switch on, you have to hit the reset button, that puts it in download mode, then you go to Arduino and say download the code, and once the code's on there, then you have to turn that switch back off. So it's a real pain, and especially as small as these switches are, they're hard to get to, and I'm sure they're going to break fairly quickly. So that's why I was thinking solder a wire onto it, an external push button or switch to do that would be real handy to do. So there is
And
that
do they
extra
give you a-
step. There is that
And
extra
do they
step
give
to
you a
use that with
pin?
Arduino.
Sorry about that. Do they give you a pin to solder on, or would you be soldering on to that actual dip switch?
I would have to look at the pins that are defined. I don't know if they bring those out. They might bring those out to a pin you can plug into. Otherwise, I would just solder a wire, get like 30 gauge wire wrap wire, and just solder a lead right onto that switch. I wouldn't remove the switch. I would just solder on the wire onto it to do something. But it's possible those are a lot of that stuff. They bring them out to the pins, even though it's doing something on the board. So I'd have to look at the schematic and see if they're doing that.
So what I think I heard is for USB programming, you physically have to touch that every time you want to upload or upload code, and then you have to put it back in run mode.
Yes. In fact, you have to flip the switch and do a reset, and then it takes it out of your program and puts it into the bootloader mode. And when you're all done, then you turn that switch back off. So when it resets, it goes back into it
That's
goes back to
pretty
just
painful.
running your code every time. So that is an extra step you have to do on that.
It's one fast board though. Holy cow. And can I ask a question about interrupts on slightly related, but on a tangent?
Go for it.
So this is the pin description. So Jeff's talk last week about trying to get his quadrature encoder working made me wonder, this happens to be a picture of my I2C rotary encoder. As you can see, the standard SDA and SCL pins there. But I did a little research on these MOSI and MISO, and I was wondering, I mean, this is how they define them in the documentation. Do you think I could attach an interrupt to either one of those?
No. What they're telling you there is you can either run I2C or you can run SPI. So see those four listing there. It says it says you can either run SCL or you can run SCL or SDA as an I2C interface, or you can run the MOSI serial clock and chip select as an SPI. So it's just a different type of interface to talk to that.
But my bet is that you could use A1 or A2 as an analog output and use that to trigger your external interrupt on a different processor, which is what I think you're wanting to do.
First,
Yeah, I was wondering if this could be an interrupt driven sensor effectively. Because right now it's an absolute position encoder. And so I've got it running at, 20 hertz, 20 hertz or so. And I'm wondering, could it be an interrupt based sensor?
Interrupting.
Well, I mean, it would be connected to, take the Black Pill as an example.
Okay, so it would be connected to the Black Pill, and you want to have it say, oh, if I'm beyond a certain value, generate this input, raise this flag.
Yeah, would one of these two pins reliably detect, as an interrupt does, a change in voltage?
Question is can you program that chip to be able to generate that?
Let me stop everybody right here and say, you have to find out what A1 and A2 mean. Terry assumed that meant analog outputs. I don't know that they are. Those might be some kind of digital pins or something. And you simply want to avoid using the I2C interface.
Yeah,
Is your point?
yeah.
Because I thought that at least the one that's in the Super Servo 200, whatever chip that is, that has an I2C interface and it has one analog output, so you can read it either way. Is there some reason why you don't want to use the I2C?
Nothing dramatic other than I would think an interrupt based detection would be more reliable than a timing based interrupt, which is what I have now.
So when you say you want an interrupt, what do you expect that to do? Is it like Terry is saying you're looking for an error, or you think you're going to communicate by using an interrupt?
I wouldn't communicate. I would just detect how many, the rotation. I mean, the fundamental purpose of this sensor is to detect rotational rotation. And right now it's an absolute encoder that's time-based. And if detecting, you know, a shift in, if there's a voltage change, or it could be interpreted as a voltage change on one of these two pins every time it rotates, it would provide some level of resolution and might provide more. I'm afraid that I might lose rotation at some time, but probably not. It was just a question. I mean, if the answer is, and Google certainly didn't find anybody who was using these as interrupt-based communication. And there were some people who were saying, no, you can't use SDA or SCL. But I just thought I would ask.
What is that chip connected to? But not on the MCU side, but
it's connected to an Arduino based a Teensy 3.2 board that's talking
how is it connected to the motor?
It's simply you glue a magnet on something and put this thing over the top of it, and just by reading the magnetic field, it tells you what angle the thing is. And he's not using it on a motor, he's using it on like steering or something.
Yeah, this is on the rear wheel. Both rear wheels have one encoder, each spitting out using this program the speed and meters traveled.
But back to your original question, no, you can't do that.
Okay.
Because the chip internally takes the two magnetic fields and does all kinds of math on it and generates a number between 0 and 4095 or 0 and 16384 or whatever the resolution is. And somehow you have to read that number out, and hooking up a simple interrupt is not going to do that. You've got two communication interfaces there you can use. So you can use the I2C to go out and read up the value, or you can use the SPI to go out and read up the value. Or if one of those pins is an analog, it does put out like 0 to 3.3 or whatever the thing is. I don't think that's going to be as accurate as taking one of the digital values out. Because I was quite surprised you could get it to work by, reading the magnet, and when it rolls over, it all seems to work out really well. And now if you're doing the analog, it's going to go up, say 0 to 3.3 and then reset to 0 again as it rolls around, and then try to figure out, get the scaling correct on the analog might be a problem, I would think, on that. If you're just doing a single rotation, the analog would work great. It tells you where you are. It's just like using a potentiometer then. So is the thing, say on your steering, if it goes from one complete rotation, it's going to go from 0 to 3.3, and just in between there, it tells you what your angle is. But when you start going multiple rotations, I think that'd be a problem trying to use the analog stuff. But I was surprised you got it to work with I2C. So
why?
Because it's got this magnetic field. I don't know how accurate that is. Is it switches from, say, 0 to whatever the maximum number is, switches between those. It just seems like I don't know how repeatable that is. Apparently it's quite repeatable if you can drive along and get, smooth incrementing numbers. You don't see little glitches every time it rolls over.
There's some noise, but it's to like the 4th decimal place.
And that might just simply be magnetic interference that's making it do that. It's just as the thing rolls over, I didn't know if you're guaranteed when it does, if that will always roll over at the same point based on the magnetic field. So
What's the resolution of that device?
It's crazy level of accuracy. It's 14 bits, 16,000 ticks, so to speak, each revolution.
Wow.
and depending which part number you buy, they got either different letters or different dash numbers or something. You can get, different amounts of resolution on those sensors too. But yeah, it's got a lot of resolution.
I'm reading it at 10 hertz. Anyway, asked and answered.
I would think that the regular reading of it would be more accurate.
Mm.
Because then you're kind of controlling what the time frame is, and you can then easily calculate based on the difference from the current from the last, be able to determine, okay, I went this many clicks in that 1/10 of a second.
Yeah, and I didn't do the math, but I think, going, if I'm doing 10 hertz, even at 5 meters a second, I don't think I'm gonna run out. But anyway, I was just curious. Because at 5, let's just say it was, I can't do the math in my head, but there is 1.5, what am I looking at? The circumference of the wheel is 1.6. So that means, I'm doing, anyway, I think I'm fine at 10 hertz. It was just a question because I could always increase that to 20 hertz. And I don't think that the chip is not going to be stressed to read that. The thing will probably do 100 hertz. But you guys probably know more about I2C and how fast it can reliably run.
And another interesting point, you could look at that chip and say, is an analog output always enabled? And can you run your I2C interface and the analog at the same time? So you could then take the analog and run it through an A to D. That's going to give you a number representing, see if that number scales to the value from the I2C that you're getting. And that I don't know if that would be worth doing all the time to verify the things are working. I think it's going to be, I think as far as the chip's concerned, those two numbers will be equated together all the time. So I don't think that's really good. I don't think you're going to detect an error based on that, but that'd be interesting to know.
Cool.
So inside the Super Servo 200, they've got a chip. I don't know if that same chip or one like that, but it's got a magnet glued on the end of the shaft, and then that's on the PC boards right over the top of that. And that chip has I2C and analog, and they chose to just take the analog pin and run to their microcontroller to get their 0 to 180 degrees or whatever out of the thing. So they're not even using the I2C on that one. So I don't know if you can configure their chip one way or the other, or if it's always putting out an analog and an I2C. So that's just another thought that I had, and I've never looked into it.
Yeah. Well, we'll see once we get out in the field how reliable the speed control is, and then we'll learn a lot once we're out in the field. But that's my priority at the moment, and not rejiggering the encoder.
When you go out to test, if you get some extra time, try an experiment where you say, get a nice spot out in front of you and say, set the servo to 25%, and see what speed you get out of it, and then back it up and do the same thing again. See if it's repeatable by just giving it, instead of monitoring your speed and trying to adjust the servo based on that, if you just set it to a speed or set it to a position, is it repeatable every time? If so, you might be able to just ignore everything else based on that.
I've thought of that because, all of this, it feels like a whole bunch of jiggery pokery to control the speed when if it's repeatable, I could just say, okay, set the servo at 279 because I know that's going to give me, 1 meter a second. So anyway, I need a runway to test that on. I need a little bit more space to do that.
Yeah, it's always handy if you've got a big open space for doing stuff like that. How hard is it to transport that thing? If you say you found a local park you wanted to drive it at, is a lot of effort to get it from there to the park? Do you have a pickup and you have ramps to put it in, or how do you transport that?
I've got a pickup with a top. The hardest part is it's not too hard. I mean, if my son's around, he can help me push it up in there. But it's a two-person deal.
And that was one of my reasons for building my thing smaller than a lawn tractor. So it, I could do it with one person, and it wasn't a point I just pick it up and throw in the back of my vehicle, but it's now gotten heavy enough that I really shouldn't do that. So I went out and bought some ramps at Harbor Freight. So if I have to, I can push it up the ramps. And my newest one, again, I took that to the extreme where now it's small enough I can just pick it up. I can still pick it up and carry it around without any problems at this point. So, and so we'll see what Terry's going to build, see how big and heavy his stuff gets, and how all that works out.
Well, my Snow 1 is still easy enough to lift manually, but it doesn't have any of the snow removal aspects to it yet.
You plan to just buy like a commercial electric snow blower to put on your bigger one, or you can just get a motor and hook up to some kind of a paddle that spins around, a paddle or brush?
To be determined. I've been looking at what's available. Like Milwaukee has I think it's a 15-inch brush, but it's an attachment, and the base power unit is also $250. So you're getting like almost $600 before you get there. And I depending on if I can find a brush like I'm wanting, and then I may have to bug Bob Storgard to use some of his metal equipment, just because I don't have anything beyond a hand drill right now.
If you look on Amazon, they've got a lot of cheap little electric snowblower things that, there's some of them are like on a handle you just push out in front of you. And it could be you can just find something you could just, get it and just simply bolt it right on the front and not have to do a lot of fabrication.
Right.
And they may even come with their own batteries. So, that'd be another thing to look at to just see how all that stuff works.
Yeah, one of the things I am wanting to be able to do is be able to change the angle of the throw.
So what direction it throws the snow?
So I'm thinking like maybe 30-degree angle off center, or going directly center for the first pass.
And when you get that far, that would be good to just, get something that you want to experiment with, and just to go out there and manually push it up and down your driveway and see,
Right.
see what you do before you start actually trying to bolt it onto a vehicle. Because, some people get this stuff all bolted together and say, oh, that's not going to work at all. So it's just easier to do that.
Yeah, I'd probably have some form of 3-point hitch or a common attachment point that I can either put a blade on or a blower on or a brush on. But yeah,
Well, the subject that Jeff is bringing up to me is all about prototype small, as best you can, because you will change your journey, and
yep,
it's a pain in the butt the bigger it is that you're dealing with.
yep.
I think you can turn off recording, Jeff.